All right, so back to example 6. We left off in the previous video introducing the mean and the standard deviation of a discrete random variable. And I just reminded you that the mean represents the typical value of a set, and the standard deviation measures the variability of a set. And we can find the mean and the standard deviation of a discrete probability distribution. So we're going to continue with example 6. Now, I just copied the discrete probability distribution for the number of passengers per car down here, just so we have it in front of us and we don't have to keep scrolling. So let's calculate the mean, which is also referred to as the expected value. So we could see example 6 continued. What is the expected number of passengers per evening? So another word for expected is the mean. So in other words, on average, how many people do we expect to see per car? Now, I always ask my students this and, how they think we would calculate the mean. And usually I get the wrong answer, which is fine, because in chapter 3, we were dealing with data sets, not probability distributions. And you're used to adding up all the numbers and dividing by the total, right, in order to get the mean. So usually the wrong answer that I get in this case is that in order to get the mean, we need to add up the values of x and divide by 5, since there's 1, 2, 3, 4, 5 numbers. Now that's incorrect. And the reason is because when you do that, you're assuming that 1, 2, 3, 4, and 5 are all equally likely, meaning they have the same probability, but they don't, right? X equals 1 and x equals 2 have the highest probabilities, 0.35 and 0.35. And then as x increases, the probability goes down. So they're not all equally likely, right? It's much less likely that there's going to be 5 passengers per car than there is 1 passenger per car. So you can't just, in other words, ignore the probability column and just add up the values of x and divide by 5. It doesn't make any sense. You have to take into consideration the probability of each one as well. So it's almost like we're calculating a weighted mean or a weighted average. So the way we do that is this formula here. And we use mu to represent the mean number of passengers per car, or the mean of a discrete probability distribution. And what we do is we take each value of x and we multiply it by its respective probability. And then we take the sum of all those products. So we're going to follow the formula for the mean down here. So we're going to take the sum of each value of x times its probability. So let's write this out. So we're going to take the first value of x, which is 1, and we're going to multiply it by its p of x, its probability, which is 0.35. Now I'm going to add the next value of x times its probability. So that's 2 times its probability, which is 0.35. Plus the next value of x times its respective probability, so plus 3 times 0.15, plus 4 times 0.10, and then plus 5 times 0.05. So now we're taking into consideration each x value's likelihood of occurring. So it's balanced, or it's weighted. So now this we just have to plug into the calculator, and you're going to plug this into the calculator exactly how you see it on the paper. So we could do this together. So first we're going to take 1 and we're going to multiply it by 0.35. So we could use parentheses as multiplication. Plus, now we're going to take 2 and we're going to multiply that by 0.35. Then we're going to take 3 and multiply that by 0.15. Then we're going to add 4 times 0.10. And then we have to add 5 times 0.05. So I literally typed it into the calculator the way we wrote it down on the worksheet. And we get 2.15. So we got a mean of 2.15 passengers per car. So we would expect, so again, imagine you're standing on the side of the highway and these cars are driving by and you're going to grab one at random. How many people would you expect to be in the car? About 2 passengers. Obviously, you can't have 2.15 people in a car, right? You can't have parts of a person, but that's close to 2, right? So we figured on average, there's about 2 people per car on this highway in the evening in this particular city. So now let's calculate the standard deviation. So the standard deviation, remember, we use sigma. So here we're not working with a sample. This is a probability distribution. So we're going to use sigma. And it's going to be equal to the following. So we're going to take the square root of the sum of each data value minus the mean squared, right? That was like the numerator of our standard deviation in chapter 3, right? We took each data value minus the mean and we squared it. But now we have to take into consideration the probability of each value of x, right? So we have to multiply by p of x. We're going to sum those up and take the square root. So we could do this together, just like we did the mean. So let's write it out and then we'll plug it in the calculator. So sigma is going to be equal to, now we're going to have a big square root, right? Because we have to plug in each value of x minus the mean squared times p of x. We have to do that 5 times, right? For the 5 different values. So first, we're going to take 1. And we're going to subtract mu, which is 2.15, right? We calculated that in the step above. We square it and we multiply it by the probability of x. And x is 1 in this case, and that's 0.35. Now we're going to do that for the next value of x. So now we're going to take 2 and we're going to subtract the mean of 2.15. We're going to square it. And then we're going to multiply that by the probability of 2, which is 0.35. Plus now we're going to take 3 minus the mean of 2.15 and square it. And we have to multiply by the probability of 3, which is 0.15. Plus now 4 minus the mean of 2.15 squared times the probability of 4, which is 0.10. And then we have to add that to 5 minus 2.15 squared times 0.05. And that's time. So squeezing that in at the very end there. So 5 minus 2.15 squared times 0.05. This seems like a lot, right? And this is only 5 values. Imagine if you had a discrete probability distribution that had 50 x values in it and you had to do this 50 times. So I am going to show you there's a shortcut on the calculator in order to find the mean and the standard deviation, but I like to show you how to do it first by hand because then it makes sense. And then we can make our lives easier and I'll teach you how to do it in the calculator. So let's plug all of this into the calculator. So the first thing, and we're going to type it in exactly as we see it on the screen. So let me go to my calculator. So the first thing we need to pull up is that big square root, right? Now, the first expression is 1 minus 2.15. Close the parentheses, right? Because we have to square that. And remember, the squared button is x squared and it's halfway down the first column. So 1 minus 2.15 squared. Now we have to multiply that by 0.35. So open a set of parentheses for multiplication, right? And put 0.35. Now plus, now we had 2 minus 2.15. Close the parenthesis and square it. And then multiply that by 0.35. Now plus 3 minus 2.15 squared times 0.15 plus 4 minus 2.15 squared times 0.10. And then last we have plus 5 minus 2.15 squared times 0.05. And now we could hit enter. And we get about 1.15. And if you didn't get this, you probably just made an error somewhere. Maybe one of your parentheses was missing. Probably it's more likely that there's a mistake with the parentheses, or maybe you forgot a squared. So just go back to what you entered and just scroll and go very carefully to see where you made your mistake. It's a lot of input. It's very easy to make a mistake. But you should have gotten 1.15. So my standard deviation is 1.15 passengers per car. And that's the average deviation from the mean. So that is how we find the mean and the standard deviation of a discrete probability distribution. So what I'll do in the next video is I'm going to show you how to use the calculator to get these same answers without having to go through the work of using the formulas. We do have a function in the calculator that'll let you calculate the mean and the standard deviation very quickly. And then we'll do another example.